Hello, welcome to Physics 21. I'd like to begin our study by talking about the notation of physics. This is a very important fundamental thing to learn. We use letters to represent values because it's much less cumbersome. And these letters are case specific. So make sure when you are learning a constant, you learn whether you use the small case or the large case. An example is the letter V. A small v is used to represent the quantity velocity, whereas a large V could either mean volume or voltage, and you would discern this from the context of the problem. We also use Greek letters. Some common ones that you should learn right now are theta, which is our notation for angle, and delta, which is our notation for change. So for example, we might be talking about any angle, we could refer to sine theta. And if to use our delta, we might want to say delta V, which would mean the change in velocity. Next, I'd like to talk about the prefixes we use when writing large or small numbers. These prefixes, we go up by 3 orders of magnitude. We don't want to do every order of magnitude. That, again, is too cumbersome. So at our base value, it would be 10 to the 0. That is just 1, just a unit quantity of whatever you're talking about. We go up by 10 to the 3rd, 10 to the 6th, and 10 to the 9th. 10 to the 3rd would be a kilo plus the base value. 10 to the 6th is a mega, and 10 to the 9th is giga. Similarly, you can go down by negative 3 orders of magnitude. You have milli, which is 10 to the negative 3. Micro is 10 to the negative 6. And nano is 10 to the negative 9th. It is also customary and much less cumbersome to express numbers using scientific notation. For example, you're going to use 6.3 times 10 to the 6 instead of writing out 6,300,000. Significant figures. Significant figures are the number of meaningful digits that a value has. For example, the value 0.25 has 2 significant figures. The 0 to the left of the decimal point doesn't count. 0.250 has 3 significant figures. While the 0 to the left of the decimal point still doesn't count, the 0 to the right of the decimal point does count. 2.91 has 3 significant figures because the value to the left of the decimal point has a value. It's not 0. When we multiply and divide values, our answer can have no more significant figures than the value with the fewest amount of significant figures. So in our example, we are multiplying 3 values. The one with the fewest amount of significant figures, 0.58, has 2 significant figures. Therefore, our answer can have no more than 2 significant figures. When we add or subtract, however, we have to look at the number of significant figures to the right of the decimal point. Our answer can have no more significant figures to the right of the decimal point than our value with the fewest amount of significant figures to the right of the decimal point. So in our example, we have 123.62 plus 8.9, and we have 8.9 has only 1 significant figure to the right of the decimal point. Therefore, our answer can have no more than 1 significant figure to the right of the decimal point.